Alrighty, now it's time for Theodore's time to shine. Definitely he messed up the bed, not me. Oh, maybe he's getting bothered because I'm talking. Anyway, we're going to talk about linear functions today, okay? And we're going to start with a little motivating example. And this motivating example is an example from yours truly. Okay, so let's look at my water and sewage bill from September of 2023. There's base costs that make up about $114 of that water bill, and that's just going to be the sewage charge, the LOTT treatment, water treatment, the base rates, the stormwater, and some random taxes. But then the actual amount of money that I have to pay based on the water used is only about 1.6 cents every gallon. Okay. So we're going to try to write the total cost for a month in my water and sewage. We'll call that C. We'll measure C in dollars. And we're going to write that as a function of how much water I used, W, in gallons. So before we jump straight to writing this as a function, which you may or may not be able to do, let's just answer a few questions. What is my water bill if I only use 10 gallons of water? Well, there's two charges, right? There's a charge that I always have to pay of $114.21. And then there's a charge for the water usage. Well, if it's this much every gallon and I'm using 10 gallons, then it's going to be 0.0161 times 10. All right, and we're going to add these charges together. You can type that into a calculator and say, if I somehow only used 10 gallons of water, not sure how that would work, it would be 114.21 plus 10 times that number, 0.0161. And you could find that my water bill was $114.37. In this case, I would only be spending 16 cents based on the water usage. And we'll round to the nearest cent here because that's how American money works. Similarly, if I used 100 gallons, it'd be very similar, right? We still have to pay this $114.21. We're still going to add the cost of the actual water that I used. It still has the exact same price, but now we're using 100 gallons. So we could just quickly update our formula right here. Let's use 100 gallons now, $115.82. Even if I use 100 gallons, it only goes up by $1.50, which is how my water bill works. It doesn't matter how much how much water I actually use. The water bill is basically the same. All right. And so now I think, we've got the pattern, right? For the water bill, well, the water bill is always going to be $114.21 plus how much I use for water. That's always going to be that same rate. It's this many dollars per gallon, and then just how many gallons I use. I'm using W here. G for gallons, I feel like would make more sense. But, anything works. And then let's write this in function notation. The cost is a function of my water usage. So now we've gotten in function notation, we've got an equation, and we're going to check our answer before I box it. If I plug in 10, I should get this number. And yeah, you can see that, right? C of 10, right? We could plug in 10 over here and get the same exact answer. We're going to get that C of 10 is still 114.37, approximately. C of 100, yeah, it's going to be the same thing we got up there, right? If you plug in 100 for W, everything else is the same. So you're still going to get this when you type it into a calculator. So this is indeed the function that shows the relationship between how many gallons of water I use and my monthly bill. So this equation is two parts. There's a fixed cost and a variable cost, and I bet you can guess which one is which. The fixed cost is the part that is fixed. It doesn't change. And this happens a lot, and not only in linear functions. This is a linear function. We'll talk about why later. not only in linear functions, but all sorts of functions. Any kind of really cost function is going to have some sort of fixed cost. If I think of like, how much money I spend on like utilities. Well, every utility is essentially going to have a fixed cost and then charging for how much I use. For electricity, for water, if you have gas, it's going to be the same thing. Or if you think about, yeah. Let's not go any further down that direction. And then the variable cost is going to be this other piece. And, it's called variable cost. It changes depending on your input. And you can see that in the term, wow, there's a variable. Okay, variable cost, it has a variable in it. Fixed cost does not have a variable in it. Okay. And the variable cost is based on a constant rate of change here. We'll talk about that constant rate of change being the reason why it's actually a line. So this number part here, this coefficient here, is the constant rate of change. We'll talk why that's the case later. This is just an introductory video. Okay. So let's graph this on Desmos and see how the fixed cost and how the rate of change affects the graph. All we have to do is modify this a little bit. Let's write this as an X. We can use it as a W. C of W equals like that. And you might panic and say, whoa, what happened? I can't see anything. Desmos isn't graphing it. Well, think about what we're looking at. I'm going to turn on my light too because this green screen thing is bothering me. It's not showing up because we're just looking from -10 to 10. We're talking about gallons of water usage and cost. I wish the costs were $5 a month, but it's way more than that. So we're going to have to zoom up. So remember, like I said before, you can just use the scroll bar to zoom. But you might also want to hit the button over here, this wrench, to manually adjust it. Okay. So again, if you do this, you can see I personally use about 250 gallons of water a month right here. So this is actually a pretty good zoom for me. But what you can see here is what I also experienced when I got this place is it doesn't really matter how much water I use from my water bill. The amount of water I use has other ramifications, but for the actual bill, it's a pretty flat slope. Notice that when the input is 0, we kind of start at $114.21. That's the fixed cost, the starting value, the y-intercept. Okay, and then the slope is where that variable is where that rate of change comes from. Every gallon of water I use, every gallon we go to the right, we're going to go up by like 1.6 cents. That's kind of hard to see here. But that's how things are sort of related on that front. Okay. So that's kind of what we're going for. Last thing I want to comment on in this video is we can model linear functions with words. That's how we started. We modeled a linear function with words up here. We can model a linear function with tables. We didn't do that here, but we could have. Model linear functions with equations. We definitely did that, right? This is how we model a linear function with equations. And we just saw it, how we can model it with graphs as well. We'll be doing all of that in this section and seeing how it appears in different ways. Best of luck. Until next time.